This is the FLSun T1 and it is the newest Delta printer in the FLSun lineup. As you can see, Delta 3D printers are unique. They are impressive to watch, offer fast print speeds, and are capable of outstanding print quality. But what about this printer, the T1? Can it claim all of those feats? And if it can, how easy is it to use out of the box? Let's spend the next 48 printing hours with this machine and find out. Folks, welcome to the channel. I am Leo of Prince Leo 3D. Thank you so much for joining me on the inaugural The First 48. What does that mean? Well, today's video, we're going to be taking a look at the FLSun T1. Now, generally when I do these review style videos, I do a pretty in-depth look at every feature of this printer. The build volume, the firmware, what you can print with it, what are the complications of it. However, in that mix, I tend to lose the initial impressions of this printer. What you can expect from when you get it in the box to your first couple prints. That's what this video is going to be, and that's what this full series is going to be. We first will get it out of the box, and we're going to see exactly how easy this is to assemble because there is some assembly required. After that, we'll see how easy it is to get the first few prints off of this printer. We're going to use the slicer that FLSun provided for us and all of their base profiles. And then finally, I'm going to give some initial impressions on what I think this printer offers us, what some downfalls might be, and what I'm going to look at further in the long review video. Of course, I'm also going to ask you, the viewer out there, leave comments if you have questions about this 3D printer, or if you want me to perform specific tests, leave a comment below. This way, between this video and the full-length review, we can get some of that testing accomplished. You can see all these awesome models sitting on the table in front of me. They all came from the FLSun T1. But just looking at a model like this TPU sandal doesn't give you the full story. How easy was this to print? That's what we're going to see now. So let's start with the unboxing and first prints of the FLSun T1. Looking at the box, it's pretty cool. FLSun has added the different lineup of printers that they have released from 2016 up until now, 2024. You'll see the T1 and the S1 are right on top, and the T1 is the printer we are focusing on today. Now, I would say in the box, the weight of this is probably around 45 pounds or so. Once you have it fully assembled, I would say this is around 35, 40 pounds maybe. It's movable, though, by a single person. I don't think you should struggle all that much if you needed to move this around your printing area. Now, when we get the piece of styrofoam off the top, we can see the different pieces looking back at us. That is the top and bottom base. That's what's going to stabilize our printer. And you can see the build plate right here. That is a PEI coated build plate. It is one-sided though. The other side of that build plate is just smooth steel, which is somewhat unfortunate. I would have hoped that they would have double-sided this PEI build plate. This is the top base plate. This is where that CPAP machine, that extremely high-powered blower motor, is situated. That is going to provide the cool air that's going to cool off our printed models as we are printing. Here we have the print head. This has the extruder on it. This has the hot end. Now, this is a Delta-style printer. That's the first time I talked about this in this video. Delta-style printers work a little differently than the common printers we see, especially the common Core XY printers. Delta printers use 3 different arms to move the print head. The exact term, or the correct term for the print head, is actually the effector or the effector. If you hear the term effector, I am referring to the print head. Here we have the panels that go around the printer. 2 plexi panels on either side, and the front door is made of glass. Arm braces that go in the rear of the printer to stabilize. And now here are the different uprights. There are 3 in total. Each upright has an arm that will be attached to the effector or to the print head, as we've discussed, and that is what will move it around the build volume. That's all we have in the box. You'll notice there wasn't too many pieces. 95% of this work is extremely simple. We're just following directions. There is about 5% of this assembly that is a little tough. Now we're going to start here with the upper base, and we're going to attach the filament spool holder. Very basic filament spool holder. There's 2 hangers on either side of the base and a metal rod that goes through those hangers that your filament spool will sit on. After mounting the filament spool holder, we're going to begin assembling the uprights. Starting at the bottom base, the first thing we do is get out the cord that is within part of the assembly. Once you clear that cable out of the way, we start adding the uprights, and there is a pocket for each individual upright. They snap in place. Once all 3 uprights are in the lower base, we add the upper base. Then, starting at the bottom, we will screw in the uprights. Like I mentioned before, this assembly is not hard, it's just tedious. We're putting in 24 screws, it's not glamorous work. Next, we'll take a look at the effector. This gets attached to 3 individual arms. Each of those arms has a metal rod at the end that gets placed inside this little ledge here of the effector, and then there are 2 screws on each side that tighten it down. And the first bit of this installation is to get the screws in place. So we're going to screw them in 1 or 2 turns. We're not going to get them fully tightened because we need to get the arms in place. Now remember when I said there was 5% of work that's really tough? This is it. Trying to get the end of these arms in place in the effector is very, very difficult. You'll notice I don't have the best camera angle for this because it was just so frustrating trying to get this done. Each arm has 2 rods that need to be attached to the effector. They are connected by a very, very tight spring. Trying to decompress these springs with your hand, open the rod, and get it in place on the effector is difficult. Now, you don't want to break anything, but you still need to use a decent amount of force. This was certainly not fun. I used a little bit of strength to open those arms and get each side into the effector and then eventually tighten it down. After the effector is in place, we're going to let loose the dogs of war, also known as the CPAP tube. We'll get more into that later in the video. We're simply going to allow the print head cable and the CPAP tube to be released from the top base and hang down. Now we can connect both the CPAP tube and the print head connector to the top of each of those individual items. We move to the upper base and we connect each individual extruder motor and each end stop switch. Now we're going to focus on that cable that we removed at the beginning of this assembly. On that front left side, we remove the inner metal panel, and that will reveal a channel. We can run this cable up that channel to its connector, which will hide it in place. We can then reseal that panel, which virtually hides this cable. Really, really nice design. I like this a lot. And they even provided an upper bracket that will hide the top of the cable. Now for the front touchscreen, we connect the ribbon cable to the rear and we snap it in place. Now to mount the camera, and this should be extremely easy, but for me, the cable that connects this to the main board was still within the base, so I had nothing to connect it to. I had to remove the panel on the lower base to access that cable, and then I can operate my camera. Not game breaking by any means, but just a little bit of an annoyance, something that quality control probably should have caught. Nearing the end, we can almost see that finish line. There are 2 brackets that go on either side or towards the rear of this Delta printer, and those will help affix the panels in the next phase. And here we go with these panels. And these panels go on really easily. There are clips on the upper and lower bases that the panels will sit in, and then only 2 screws that affix the panel to that inner bracket. If you're not interested in printing materials that need an enclosure like ASA or ABS, you could always just keep these panels affixed with the hooks at the top and bottom base and not screw them in, so you could take them off if you like the look of it better. It's really up to you. I do like the design of how they did this. Lastly is the door. There are hinges already affixed to the front left assembly where we can line up the door and screw it in place. There's also a handle provided to us that we attach to the outside. Before we power this on, we're going to go to the rear of the printer and make sure we've set the voltage to what is correct in our area. I am in New York, so for me, it is 115. You can do this by inserting a large Allen key into this hole and toggling the connector switch. It is hard to see in there, so afterwards, take a flashlight and verify that you have the correct setting. Before moving on, I'd like to thank today's video sponsor, PCBWay. PCBWay.com is a great resource when beginning any new DIY project. Besides making custom PCB boards for your electronic needs, they also provide additive manufacturing services like CNC machining and sheet metal fabrication, which can be an interesting new avenue for those of us who are already into 3D printing and want to see our creations brought to life in even more materials. Now, if you don't have a project to start, you can find some inspiration on their projects page, where you will find a near endless supply of fun ideas, which will include a detailed guide and list of materials for everything you will need. So give PCBWay.com a look and see what it can offer you. After plugging the machine in, we can turn it on and watch this touchscreen come alive. The setup for this printer is very straightforward. We begin by selecting a language, and then we can find our local network and we can connect our printer to it using the password. This printer is running Clipper firmware, which means we have access to it via a web page through our local network. So it would behoove us to hook it up to one right now during the initial setup. Then we begin a self-inspection. It starts by checking heating elements in the bed and the nozzle, and then checking the operation of the stepper motors. Afterwards, it begins vibration compensation. This is also known as input shaping. That means there is an accelerometer built into our printhead that is going to collect vibration data. It will use that data to counteract any vibrations that may be put on this printhead while it is printing. This was also the first time I heard that CPAP machine kick on, and oh boy, is it loud. This remained an issue throughout all of my testing, something we'll talk about right at the end of this video. After vibration compensation, it goes into a delta calibration, where the nozzle will probe the bed in a few points, collecting some data, storing it, and then using during subsequent prints. The last step in this process is to create a bed mesh. The nozzle will probe several points on this bed. It will collect height data. It will turn that into a virtual mesh that our printer will use while it's printing the first 10 layers or so. This will ensure we have even first layers and great adhesion. Once the self-inspection is done, we are returned to the home screen, and it is up to us to load some filament. I am using FLSun provided high-speed PLA, and I'm using the touchscreen to load it using all of the controls that they offered us. So now it was off to the slicer to load in a model and start printing. During my first 48 hours with this printer, the only slicer available was the one from FLSun, so we have to first download that. I don't know why these companies are forcing us to use their version of some forked slicer that already works, but yet here we are, they all do it. And in this case, we are using FLSun Slicer, which is a fork of Prusa Slicer. There is a configuration wizard when we first open it up, and you can go through all the different menus if you want. Really what we're interested in is we want to make sure we import the FLSun T1. It's already checked for us, and it's going to import all the profiles and data we need. And it's only going to come equipped with profiles for a 0.4 millimeter nozzle, which is fine for us because that is what the printer comes with standard. After you're finished with the configuration wizard, you should open up to a build plate. Now, if we look to the right here, we'll see the printer that is default is the S1. We want to go drop down to the T1. This way, the build size and build volume is all accurate. Again, if you are familiar with Prusa Slicer, this should feel familiar to you. We have a simple, advanced, and expert versions of the details we're going to see. So if we break everything down, the printer is at top. The gear icon brings up all the different printer settings. For us, the only thing we have to worry about right now is the nozzle size. It's correct. Under the filament, that's where we're going to make modifications to the temperature of our filament, the temperature of our bed, as well as when the fans are going to go on and go off. The final area we can configure is the print settings. We touch that gear icon, and there is a plethora of different options found under here. Now, I'm only under the simple version. As you can see, right up to the top right here, it shows you green color codes to simple. If I was to go to expert and now bring up print settings, you'll see I have a lot more options to choose and to tweak from. So this is something you can go and explore yourself, but right now we're going to print just a very simple cube. We've loaded the PLA, and I want to see what kind of first print we can get with doing little to no work. Now, the first thing we should do is add our device under the device tabs, add printer. We're going to add the printer we're using, give it any name you want, and then underneath there, you're going to add the IP address. Select OK, and you should be brought to the printer's web page. Now, this is all Clipper we're looking at, and specifically, this is mainsail. That's what this little symbol up here denotes. So if you were familiar with the mainsail front end as opposed to fluid, this will be very familiar to you. So once our 3D printer is connected, we can go back to the prepare screen. I'm just going to right-click, add a shape. I'm going to bring in a box, just very simple. We don't want to do anything crazy. I have my T1 printer selected. If you drop down the different filaments, you'll see the profiles that FLSun has already set up for us. We are using high-speed PLA, so that's what I'm going to check. I'm going to go with the basic 0.2 millimeter print profile, and I'm going to slice it. If I wanted to, I could look through it. Once it looks good to me, I'm going to go to the Send G-Code button, and this will now send this directly to my printer. I can upload it to my printer, or I can upload it and go directly to print, and that's what I'm going to do, upload and print. And now if I go back to the device, I'll be able to see it has started printing. The temperatures on my hot end and my bed have adjusted to what they should be, and the 3D printer will begin shortly. Directly from the slicer to our build plate, and our cube is now finished. And I have to say, this is one of the nicest, if not the nicest, printed cube that I've ever produced. This has sharp corners, even layer lines, and the extrusion is completely consistent throughout. I was blown away by this. And white is not a very forgiving color when judging the quality of prints. You will notice any imperfection. After that, it was time to try a larger print. And this DeadPool bust by Eastman was, I thought, the best example. The first layer on both of these first two prints was picture perfect. And you can see here just how quickly this 3D printer is moving. These deltas are so awesome. They look so futuristic while they're operating, almost like a scene from The Fifth Element. And when this DeadPool bust was done, it was nearly perfect. Now you will notice a few little wisps of filament here and there. Nothing that really concerned me, but under the arms of this DeadPool, there is always issues because these are significant overhangs. And this had 0 print artifacts, blemishes, or ripped layers. And I always see some sort of imperfection there. Print number 2 down, and it was stunning. After that, I switched out the FLSun high-speed filament for some Ace Additive high-speed filament. This was a fairly large print on the bottom with a unique design going up the sides. And again, the T1 accomplished this without any issues whatsoever. And then I finally got a chance to print this Prusa rocket engine that I've seen so many people produce. This is an awesome model, printed without supports, and I wanted to see how well the T1 could handle it. And again, to remind you, this is out of the box with no calibration. This PLA print came out amazing. And before we go to any new materials, I wanted to tackle the elephant in the room, and that is this loud and large CPAP parts cooling fan. This printer is far and away the loudest printer I've ever encountered. My wife and I could barely get through an episode of House of the Dragons a floor above this printer without being distracted by the noise. I woke up at 2 in the morning on my second story and I could still hear this printer chugging away. So if you are thinking about buying this printer, consider where you're going to be using it because this thing is loud and you will hear it from wherever you are. It was time to tackle a new material and I began with PETG. This is Uri-1 Galaxy Black PETG. It has some sparkle in it and it's pretty old, been sitting on my shelf for around 2 years now. And the most notable quality is its low melting point, which may become a factor in my subsequent prints. The first PETG print came out perfectly. However, the second one began to give me first layer issues. The nozzle appeared to be too close to the bed. It was so hard to get the first few layers off of this PEI bed. What a struggle. Before I dove into this issue, I started another print, and this time it printed a little better. The print completed, but the first layer was still a little smushed, and you could even notice a small blob in the first layer. It actually came up while it was printing and stuck to the nozzle at the end. Considering this might be a specific filament brand issue, I wanted to try a different material and a different brand, so I chose to print in black ASA from Polymaker. The first print was a small clip that I had designed, and it printed very well except for a minor imperfection in that first layer that you can notice here. It was also at this time I noticed an issue with the filament spool. Due to the placement of the filament and the operation of the effector moving up and down, yanking on that filament, between prints, this can cause slack in that filament spool and can cause the filament to tangle. And while this printer does come with a filament runout sensor, it will not notify you if the filament is just tangled, only if the filament is exhausted. Something to keep in mind going forward. between prints, you may have to take up that slack in your filament spool to prevent any tangling. After clearing that tangle and starting a new ASA print, the T1 was back to producing high-quality, accurate prints. I was satisfied with how well this printed ASA, so I wanted to move to yet another material, this time a flexible material, and that was TPU. TPU is one of my favorite materials. It has so many applications, it has so many strengths. However, it can be a little difficult to print. Now you'll notice the effector is moving a lot slower while printing TPU. That's because we need to print at slower speeds, topping out at a maximum flow rate of 3.8 cubic millimeters per second. These TPU prints came out really, really well. We started with a Voron cube, and then I went to a full sandal set. This was also the first time I used supports while printing, and these TPU supports pulled off like butter. I was very, very impressed with how well this printed not only the main parts, but the supports as well. As the 48 hours ticked to the end, I wanted to give a little glance at the firmware. I wanted to go to the printer's webpage and check out some of the configuration files and the commands that I can issue it. In order to access the web page, we need to open a web browser and input our IP address that is connected to our printer. And you can find all that information right from your printer's display screen. Once I open it up, I have access to the full dashboard. And as we mentioned earlier, this is main sale of the front ends that are offered to us. Now, at first blush, everything looks fine. When we look at our configuration files, they look neat and they look orderly. Everything seems to be in order. It wasn't until I started to do a little more exploring that things went a little sideways. Whenever I tried to heat the hot end up from this screen, I noticed after a certain amount of time it would power down without giving me any sort of indication of why. Now, if I drop this console down, you're going to see why. It would appear every 3 minutes this 3D printer is issuing a temperature kill command. M104S0 is a printer command that sets the nozzle temperature of your printer to 0. It is doing that every 3 minutes. So you will see here at 12:36 a.m. I am setting my printer's temperature to 230. From my cursory glance of the configuration files, I cannot find out where FLSun has hidden this command to automatically send it every 3 minutes. To me, that means they are issuing commands outside of Clipper through their own usage, and they are not giving us SSH access to this printer so we can see exactly what they're doing. Now, that can be a huge red flag. I have not dug in too deeply to the configuration files. I did reach out to FLSun about getting SSH access so we can poke around and see what's going on. And their response was that they are not giving SSH access, but they will answer questions as they come up. And here we have it. 12:36. It is now 12:39 at my time. There is no command issued for M104S0, but my extruder has turned off. So not only is this shadow killing the temperature on my extruder, it's also not even sending it to the console. Even weirder. I send a command, it turns it off, it's not telling me why. Whereas all these naked commands are coming to turn it off without any intervention. Very, very strange. Now, this only scratches the surface of things that you cannot do. I have not tried to look into the input shaping, the resonant compensation graphs yet, flow rate, acceleration control. All that stuff may be controlled behind the scenes, and that is something I need to look into much, much deeper. So that has been my first 48 printing hours with this machine, and now it's time for a little reflection and a little wrap up. Firstly, this is a 3D printer that needs to be assembled. Back in 2022, that was just par for the course. We expected it for every printer. Nowadays in 2024, it's a little bit of an inconvenience. Now, we really should not be complaining about assembling a 3D printer like this, especially when most of the setup was pretty easy, but it is going up against other competition, especially competition for your time and your money. The Kingroom KLP1, the Chitty Q1 Pro, the Chitty Q1 X Max 3, as well as all the Bamboo Labs series of printers. Those are basically ready to go directly out of the box. You can be basically up and printing in 15 minutes with those. So the assembly is something we should definitely consider if we're considering moving forward with this 3D printer, but overall it really wasn't that tough for me. The only thing that was an issue was getting that effector put together. And then after that, getting our prints started and going was very simple. I was able to pretty much blaze through 4 different materials: PLA, PETG, ASA, which is obviously very similar to ABS, and then TPU, our flexible of materials. Now, I was doing all my slicing through the FLSun slicer that they provided for us, and then uploading it directly to this 3D printer. This printer seemed to operate at its peak when I was using FLSun slicer, sending prints directly from there, and then also using the touchscreen to operate it. Going through all the different prints, I only had issues once with the PETG print where the nozzle was way too close to the bed. It was 2 prints back to back, and then after that, it seemed to correct itself. Now, of course, leveling, how the nozzle does its leveling interpretation and its bed mesh, something I'm going to look forward, or something I'm going to look into in the larger base video, the review video. But right now, everything seems to be working as good as we can expect, especially without doing any calibration of our own. The scariest issue for me was when I tried to operate this 3D printer through its front end. I am pretty versed in Clipper and how to operate it, and there were certain things that I tried to do that this printer would not let me do. We saw that one time when I was sending temperature controls, and this was shadow killing the temperature. That really shouldn't be happening. We need to know what's going on in the background, and right now, FLSun is not offering us that ability. We need to be able to SSH into this printer so we can see all the different files and folders and how they're operating together. We don't have access to that. That is scary. That means if we want to add features to this 3D printer, like Octo Everywhere, something that can use our camera for AI detection, we cannot do that right now because we don't have that SSH access. It also means that we don't really know what other commands FLSun is putting in the background, and we can't safeguard ourselves against anything they may be doing that they shouldn't be doing. Now, I don't want to be Chicken Little. I don't want to say the sky is falling, but it definitely gives me pause when considering a printer like this. They are using Clipper firmware because they need to compete with Bamboo Labs and all these high-speed printers that allow instant access, web page access. They're using Clipper for that, but at the same time, they're fencing Clipper in and they're not giving us access to it like they should. So that is just a little scary and something I'm going to dive into deeper as we look further into this machine. Now, there are some other features that I never got a chance to check out that we're going to in the larger review. Besides the things I already noted, there is a filament runout sensor in here that I want to make sure that it works properly. I'd like to break down the hot end and the extruder and see exactly what's going on in there. I want to take a look up at the CPAP machine, see if we can quiet that thing down, because that is another issue that you may face if you are considering this 3D printer. That CPAP machine is extremely, extremely loud. Is it a deal breaker for you? It's really hard to convey noise over a video like this. For me, all these printers are making noise. It's white noise to me. It doesn't really bother me when I go upstairs and close the door. This printer, though, was definitely making noise even when I shut my door and we were trying to relax in another room. It wasn't keeping us up at night, but at the same time, I could tell it was running, and it was a minor annoyance. Also, I want to take a look at what the exact build volume for this 3D printer is. Now, of course, it is 260 in the diameter, but the height is labeled as 330 millimeters, and it really isn't. Due to how the Delta printer works, the print head can't actually reach every part of that 260 diameter while it's at that 330 millimeter height. I believe our height's going to be somewhere limited to 280 if we want to get that full 260 diameter. Something I'm going to look deeper into for the upcoming review. So that was a look into the first 48 printing hours of this machine, the FLSun T1. I had a great time. This video was so much fun to produce. If you watched this for, I thank you. I poked fun at myself a little bit here and there. That whole intro is kind of just slapstick fun. It was really, really fun making this. So I want to keep making these videos. So if you thought it was a little too over the top, I apologize, but it definitely made my days and nights while I was producing this. If you have not already, join the Discord. There is so much conversation going on there, so many prints to show off, and so much knowledge to glean from everyone that is offering it there. As always, I want to thank all my supporters on Patreon. Thank you, thank you, thank you. More videos coming up. I have a KLP1 large version in the box right there. We're going to do a 48 hours. We're going to do a review. We're doing Octo Everywhere next. We have a few other printers coming out. I'm going to do nozzle sizes, flow, acceleration, all these different things coming up down the line. I'm trying to clear my schedule, trying to make these videos work a little easier for me. So I thank everyone for their support, the kind comments everyone leaves. It really makes my day. It makes this, it gives me the motivation to keep doing this. So thank you so much. And now, until next time, as always, boys, girls, everybody else, keep on printing.